Hi everyone, so I have a time-lapse video of this particular 3D print and this looks okay, but this is not suitable for Instagram or YouTube shorts because this looks too jittery and it's a bit too slow. If I were to fast forward it, this does not look good. So I'm going to write a Python code to make it much smoother so that we get a very nice stable video as an output. So normally if you want to do this, there are other options. You can buy some specialized cameras or you can modify the G code and do some things, but that's too much for me. So I'm just going to use some Python and use some template matching in order to get a smooth video out of it. Alright, so if you're following along, before you get started, ensure that two of the libraries are installed. So we'll be using two libraries. One is OpenCV, the other one is NumPy. You can install them by typing pip install OpenCV Python and pip install NumPy, or you can just give a space, either works. So let's import them. Import CV2 and import NumPy as NP. So we have imported the two libraries. Let's also import our system. So first things first, let's try to read the video. So we have this particular video. Let's try and reading the video. So you can say capture is equals to cv2 dot video capture. So we can use this function to read a video, and we can provide the video path over here. So let me copy paste the video path. Just ensure that you're removing the double slash, the backward slash, not removing, just add a new one. Backward slash implies that for new line characters and tabs we use a backslash, but here we are just, we want the path, so just add another backslash. Alright, so now let's check if the capture is open. So for that what we can do is for if cap dot is open. So this is going to be true if we have successfully opened this video, and this is false if we could not open this video. So what I can say is if not capture is open, then I want to print a message saying that error opening file and system.exit1. I want to stop the code if we are unable to open the capture. Alright. So now let's try to go through each and every frame of the video, and then let's try and print, let's try to show them. So for that what we can do is we can use a while loop, while true. So we can say capture.read. So this is going to return two values. One is the return and the other one is the frame. So the return value is going to be false if we have reached the end of the file. It is going to be true if we have successfully read a frame. So what I can say is if not written. So that means if return is false or if return is not true, we will print done. So we have processed the entire file and then we want to break out of this loop. If not, we'll continue. So now we have this frame. So let's try and display the frame. For that we can use cv2.imShow. That is going to show the frame. I will just call it frame. You can give any name over there. I'm just calling it as a frame, and then provide the frame where you have the image. Okay, so this is going to display the frame, but it is going to immediately close. So we want it to wait till we hit a key, or we don't want to close that immediately. For that we can use something called as a wait key of 10 seconds, or sorry, 10 milliseconds. So this is going to show each frame for 10 milliseconds, and I'll say key is equals to. And the other thing that I want is if I hit Q on my keyboard, I want this to stop. So for that what I'll say is key equals to that. So if key is equals to orb of Q. So this is going to check if the entered key is a Q. If it is a Q, then we want to break out of it. We want to break out of the while loop. So let's try to run this. Print Python main. Alright, so this is working, but yeah, this is way too big, so let's resize that. So to resize, we can use cv2.resize function. So within this resize function, I can provide the frame, and then I can also provide the new resolution. So I'm going to hard code 350 by 600. Just because it might not be in the exact aspect ratio. Just for debugging, this should be good enough. Yeah, so this is good enough. So you can see that the video is playing just fine. Alright, so now that we are able to read the video from the video capture, let's try to do some template matching. So let's start by picking up a frame where we have ender, this particular ender over here. So what I'm going to do is I'm going to capture all the frames where the bed is exactly at the same position. So over here the bed is at this position, and I want to skip all of these frames where bed is at a different position, and I want to capture again this frame where bed is at this position. So how will I do that? For that, let's take a screenshot. So you can go to video, take a snapshot. I'm taking the picture of this particular frame. After taking a picture of that frame, let me go to the pictures and open this. So this is the picture that we have. Let me rotate this. So I want all the frames where the bed is exactly at this position, and we are tracking the bed by using this ender text. So let's try to crop it out so that just the ender is visible. En. So crop it out and then you can save it. So I have already saved it. So let me just show that to you. Let me go to my downloads, and yeah, so this is the image that I have with me. So we are going to use this image as a template, and we are going to find out that image in this video. Alright, so let's load the template now. Template is equals to cv2.imread, and let's read the template. So for that we need to copy the path. So I'll select the template and copy path, and just add another backslash so that we don't get any errors. Done. But the thing is, we want this template to be black and white because the template matching only works for a black and white video, and it does not for a black and white image, but not a color image. So for that reason, let me convert this to black and white. So for that, I can use cv2.imread, cv2.imread grayscale. So this is going to convert the color template into a grayscale one. Let's also visualize this. cv2.imshow template. I'll just call it as a key, and cv2.wait key. So when you're providing wait key as 0, it's just infinitely going to wait till you hit any key. So let's try that. Yep, so it has read the template, and it is looking good, and it is converted to black and white. Let me hit some key and it is resuming. Good. So the next step we need to do is, let me just delete this. The next step is to do the template matching. So as I've just mentioned, the frame is in color. So let's change that to black and white. So for that, I'll create a new variable frame gray. The frame gray is equals to cv2.cvt color. So this function is going to take in an image. In this case, it is a frame, and convert that to the desired color. So in this case, I want it to go from BGR to grayscale. Done. So now we have a black and white frame. So the next step is to do the template matching. In order to do the template matching, we will be using cv2.matchTemplate function. Match template. So this is going to take the frame and the template. After that, the method. So there are multiple methods. In this case, I'm just going to use coefficient normalized. So you can go over to the OpenCV website and see what are the different methods that are available. But based on my experience, I see that this is more useful. This is more. This will work for our case. So this is going to return bunch of results. So let's capture them in a result variable, and then let's create a threshold as well. So this is going to detect multiple. It's going to detect multiple items on that. So we want to ensure that the confidence is at least 80%. So for that reason, I have created a threshold of 0.8. So that is around 80% confidence. Now I can say np.where the result is greater than or equals to the threshold. So we are capturing all the cases where the threshold is greater than, the confidence is greater than the threshold, which is 80%. All right, so after you have found the location, let's count the number of locations we have found. So for that, what we can do is we can print length of the locations of 0. So let's do that. Let's run the code again. Okay, so each time it is detecting 50 different bounding boxes for the same template. But we don't really need 50 different same bounding boxes. So what we're going to do is we'll write a simple if condition. That's we're only going to take the first one. We don't really care about the others because the coordinates will be very similar. So let's print it for now. Let's say print location, and then I'll break it over here. So by running this, you'll see that most of the y, these are all the y coordinates, And these are all the x coordinates, and you can see that the x and y coordinate of a bounding box is pretty much similar. So it is 2863, 2863, 2864, and so on. So it's pretty much similar, and y coordinate is slightly changing by 1 or 2 pixels, 726, 727, 728, and so on. So basically, it is detecting multiple bounding boxes for the same given template, and we don't really care about it. We just want the first. So what we are going to do is we are going to get the first location, and we don't really care about the others. So to access the first x and y coordinates, all we need to do is create a variable lx that is equals to location of 0 of 1. So that is the first location x coordinate, location y. Let me rename that to location x. So location y is equals to location of 0 of 0. So in this way we can get the first y coordinate and x coordinate, and in case if it doesn't match anything, we want to go to the next frame. So for that we can write a simple if condition. If length of locations of 0, if that is equals to 0, which means that we haven't found anything, so we did not match anything, in that case continue, move on to the next frame. So it'll just go over to the next frame and then it will continue again. So let's add this, and if we were to detect a location, now we have a location x and a location y. So now let's try to visualize this. So it's nice that we have a location y and location x, so let's do the visualization. In order to visualize it, we'll use cv2.rectangle. So we'll draw a rectangle around the frame. So cv2.rectangle, I'll call it as a frame. And then I'll pass on the points. So now the points are going to be x coordinate location x, and the y coordinate is going to be location y, and coming to the point 2, it's going to be location x plus width of the image, and location y plus height of the template. So if you remember, we have already taken this particular template image, we have the width and height of it, so we are going to pass on them so that we can draw a nice rectangle around it. And the next parameter is the color. So for now I'll just give it as a green color. So the color is in blue, green, and red, so that will be 0, 255, 0, and I'll say the thickness is equals to 4. Right, so this is going to draw a rectangle around the frame or the template, and then that is getting displayed over here. So here I see that we are displaying a gray frame, so let's change that to the color one so that we can see it. So let's run this again, and then yeah, we have an error. See, so the issue is that the length is only supposed to be for this, not for the entire thing. Well, this is working fine. Let's stop it over here, and then let's fix this as well. This is supposed to be 1 of 0, and then try again. Right, so you can see that we have a bounding box around the ender, so it is properly being detected. So let's quickly stop this, and if it is difficult for you, let me increase the width of the line. So let's try again. So here you can see that there is a bounding box around the ender, so we are tracking the location of the bend. But as you can see, it is quite slow because we are detecting this particular template throughout this entire image, which is not really necessary. Right? So we know that the bed location or the ender, this is only going to move within this area. So it's not going to cross beyond this area, and even if it crosses beyond this area, we don't really care. We just want to track it within this area of the image. So for that reason, what we are going to do is we are going to just track the track this particular ender or the bed position only in this area of the image. So let's get the coordinates. So the xy coordinates are 553 and 2590. Let's note them. X offset is going to be 553 and y offset is going to be, let's see, what was that, 553 and 2590. So we're going to use these as the offsets, and then I'll say x y width or YL. I'll just call it as YL, and that's going to be this one. So we don't even have to track till here. We just need to track till here. That should be enough. So this is 1137 by 3554. Okay, so I'm going to call YL as 3554 and XL as this one, 1137. So we just have to drag our template within these coordinates of the image. So let's do that. In order to do it, what we can do is let's go over to the match template and frame tray. Over here, rather than tracking everything, let's provide it Y offset plus, so Y offset till YL and then X offset until XL. So we just want to drag this particular template only on this part of the image. We don't really care about the others. But now the thing is, if you look at this location X and location Y, they are based on the global scale, which means that the X and Y over here represent this particular X over here. So what we have to do is we have to add the offset over here as well. So let's just add the offset X offset plus Y offset. So now we have the offsets. Let's try this again and see if it is working fine. Yep, this is working great. So this would definitely improve the performance. As you can see, it's detecting more frames much faster. I'll stop it over here. Okay, so that is working fine. We are detecting the frames. But that being said, we don't really care about all the frames of the image. We just want the frames where X and Y is at a particular location. So let me zoom in a bit. So we have this ended. So we all we need to do is check the Y coordinate. Let's take the XY coordinates of this. So currently it is located at 773 and 3076. So let me note that down. Y limit, I'll say that we don't really care about the X coordinate. So looking at the Y, I would say it is at 380, 3080. So I'll call it as Y limit 1 and then Y limit 2. That is going to be, oh, this is 3080. So the second limit is going to be, let's say, slightly below this. I'll just give it as 390, 3090. So I want to track the frames, or I only want the frames where the X and or the Y limit is in between these two locations. So let's write a simple if condition. Now that we have the location X and location Y, what we can say is that if the location X is, let's say if it is less than our Y limit 1, so if it is less than Y limit, or if the location Y, oh, it's just the Y not X, so let's change this. If the location Y is greater than Y limit 2. So if it is beyond these particular limits, we want to continue. We don't want to process this. Okay. So in this way, we are tracking the X and Y coordinates. So let's try to run this again and see what happens. Okay, so this is correct. It is displaying the correct frame. And as you can see, it is only displaying the frames where the bed position is exactly over here. The print head moves, but the bed position doesn't change. It is going through all the frames in the video, and it is just picking out the frames where the bed is exactly at this position. So now let's break this. And then what we're going to do is we are going to save these frames. So let's save them in a new folder. So let's create a new folder, call it as selected. So we'll save this frame. In order to save a frame, all you need to do is cv2.in write and selected folder. Let's give a name. So I'll call it as F. So let's get the current frame number first of all. To get the current frame, in order to get the current frame, what you can do is cv2.get. You can use not cv2. You can use a capture.get. cv2.position. Let's see, capture dot position frames. So this is going to give us the frame at which we are currently located. So let's say the image name is going to be same as the frame name. So frame.png. So this is going to be our location of the image, and the image itself is going to be the frame. Okay, so in this way we can write the frames, but ensure that you are disabling cv2.rectangle because we don't want to display anymore. That's just going to slow the code. And also, if you're going to draw some rectangles on the frame, those rectangles will stay in the output, which we don't want. And then let's add some progress bar. So for that, let's show some progress. So what we can do is we can print another f string and do the same. Let's get the current frame. Let's show the status here, current frame over total frames. Total. So how do you get the total frames? So in order to get the total frames, let's do it over here. So you can say that capture.get cv2 dot capture underscore crop underscore frame count. Yeah. So this is going to give us the total number of frames. So I'll mention the same total frames. So now we have the total number of frames, and the total number of frames are displayed here. So this is just going to quickly show us at what frame we are, and then yeah, I think that's good enough to display the progress. And the next item that I want to do is after we have detected it, I want to skip by, let's say, 100 frames. Current frame plus equals to, I'll mention 200. Let's skip 200 frames every time. We don't want to look at once we have successfully captured the good frame, we want to skip ahead by at least 200 frames. We don't want to again recapture the immediate next frame. That doesn't look good in the final output. So what we can do is we can add 200 to the current frame and then just set it back again. So capture dot set the current frame position to current frame. So this is what we can do, or I can add plus 200 because that looks more that makes more sense, and remove it here. Alright, so let's try this again. Let's see if we are getting the outputs. Yeah, we are getting the output. So here you can see that it is 5. We are at the 5th frame out of 20,070 frames. If you look at it, it is 5.0. So let's make sure that this is an integer. And then let's try that again. Okay, so there's a typo in this folder name, but now it is working. So it is displaying the frame number. And also for the current frame, let's change this to integer. Let's break this. And let's say that rather than printing this, let's say that we want to print the status at every nth frame. I think that would make more sense. So let's go over here, and after we get the frame, let's just print the current frame that we are at by total frames if the current frame is divisible by 50. So let's do this so that we are printing the status after every 50 frames that are processed. So I'll cut it out here and I'll paste it on top. Alright, if current frame percentile is equals to 0, we need to mention that. So that's why it is printing randomly. So let's try that again. So this time it should print the status after every 50 frames. So okay, we are at 250th frame now. 300. Let's see how many images will be selected. So this is going to take some time. So let's just leave it and see how many frames will be captured by the end of this process. Okay, so it's not selecting a lot of frames. So let's increase the limits. So rather than making it just 10 pixels, I'll just increase it to 370 and 100. So in this way, we are looking at a 30 pixel range. So let's quickly try that again and see if it can detect more frames. Okay, so now we are starting to detect a bunch of frames. That is good. Let's check them. Okay. Yeah. I think this is slowly working. So let's take a look at the final output here. Nice. So as you can see, as I'm scrolling through the frame, this is already looking much better. So hi guys, so a couple of changes. So rather than using current frame, just create a new variable n, where n is equals to 0, and then use that over here and increment the n. And after that, just use a very big number over here, one after one followed by a lot of zeros, so that this will make it much easier when you're using DaVinci Resolve or some other tool to sort out these images into a video. So for that, I've made these couple of changes. Okay, once the code is done executing it, I have 326 different images. So let's quickly verify and see how it looks. Jump over to your selected folder and then just click on right button and see how it looks in general. So it looks decent. So this is looking very good. Now what we can do is we can combine all these images and create a video. So for that you need DaVinci Resolve. So if you don't have it, it's a free tool. Install DaVinci Resolve, and once you have installed, go to the media library. So just go to this particular tab, and within the media tab, navigate to your selected folder. So if you open the selected folder, you will find three different sequences. So by default, you might not see this. Click on the three dots that you have here, frame display, change from individual to sequence. So that is going to display the sequence. So here it is showing sequence starting from 1, 10, and 100. So just drag and drop all of them. We want all of them. We want ones, 10, and 100 in the same order. So now let's jump over to the cut. So over here, do the same again. Place them in 1, 10, and then 100 in the same order. Alright. So now you can take a look at this. So let's play this. Play. So you see that we have a good time-lapse video of, sorry, I'm recording, so this might be a bit jittery for you. So we have a time-lapse recording that looks much better. And this recording is of, let's see, 13 seconds. So a 13-second video, that looks really good. And you can go ahead and export this model or do some sort of corrections to this and then export it again. So in my case, I'll select YouTube and I'll just call it as time-lapse 3D. And I'll just place it in my downloads folder. Add to render queue and finally render all. So once it is exported, this is the final output. So let me play this. So this is a 13-second video of the time lapse. So this looks much better than the first one. Thank you for watching.